Hi everybody. We are going to start discussing the 2020 chemistry MCQ paper. So what we're doing here is like we're going through all the MCQs and we're discussing in great detail the theory behind all the questions. And I would like if you can do the paper before the discussion, right? And do the questions, try your best, and then listen to the discussion. And then write the special points down in a separate book. Just write chemistry 2020 MCQ review and then use a separate book and then write those points. So just try to concentrate really well in each and every video that I'm publishing, right? So try to get maximum out of this video, get a lot of knowledge and then further add your own details to the review that I'm giving. Right, so let's start with the first question. So what's the first question telling you? Consider the following discoveries made with regard to the atomic structure. Right, so the first one is positive rays inside a cathode ray tube, radioactivity by certain types of nuclei. The two scientists who discovered the above statements 1 and 2 respectively are. So it's a very easy question from the first topic. So positive rays inside a cathode ray tube, who found that? Actually it was found by Goldstein. So Eugen Goldstein. And if we talk about radioactivity by certain types of nuclei, who's responsible for discoveries of radioactivity? It's actually Henry Becquerel. You know, you're using the units of Becquerel laws in physics, right? Yeah, and also just write these additional points like this, like Millikan discovered the charge of an electron quantitatively. You can write that point. Millikan discovered the charge of an electron quantitatively, because next time they can ask this. And also you can write the point, J.J. Thomson, he found out the EM ratio, charge over mass ratio. Okay, so you can write those 2 points as well. And just look at Rutherford's Guilford experiment, right? And you can go through those topics because next time they can ask these topics, right? So the answer is the fifth one for the first one. Right, second one. The number of electrons in the manganese atom, which is having an atomic number of 25, that have quantum numbers L equals 0 and ML equals -1 respectively. So they are talking about separate numbers of electrons, no? For L equals 0 separately and ML equals -1 separately. Is that clear? All right, let's see. Now, manganese has an atomic number of 25. Okay, I write the electronic configuration of manganese. What's that? 1s2, 2s2, 2p6, 3s2, 3p6. Then what? 4s2, and then 3d5 is how you write it. So we have 20. 5 atomic number, so 25 electrons. Okay, so 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, and 4s2, right? Okay, now look at this. Now they're asking for the number of electrons in the manganese atom having quantum number of L equals 0 first. Okay, L equals 0. What's the meaning of L equals 0? Why is L azimuthal quantum number? You know, like the sub-energy level, it has an azimuthal quantum number of 0. When the azimuthal quantum number is 1, we represent the p sub-energy level. When it's L equals 2, we represent what? The d sub-energy level, right? That's it. Right, so 0 for S sub-energy level, 1 for p sub-energy level, 2 for d sub-energy level, right? So these are just numbers helping you to identify these sub-energy levels. Right now, S sub-energy level, where can you see that? You can see it here, 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 and here. Now, if I represent the orbitals, like S orbital here, it has 2 electrons present antiparallelly, right? You know these theories. So this is an orbital within the box. I represented the orbital within the box, and then have 2 electrons having opposite spins. So you can see the s orbital holds a maximum of 2 electrons, and you can see the 2 electrons here. Now, how many such s orbitals are there? 1, 2, 3, 4. So 4 s orbitals having the azimuthal quantum number of 0. So then 4 times 2, you get what? 8 such electrons. So that answer is decided first. Now see, we have 8 and 8 in answers 2, 3 and 4. But in 1 and 5 we don't have 8, so we can exclude 1 and 5. So immediately when you're solving such questions, exclude 1 and 5 immediately. Therefore the chance of you getting the answer right is more, right? So yeah, that's a very important point. But then obviously we have to find the next thing as well, which is ml equals minus 1. How many electrons have this ml equals minus 1 value, right? Okay, what do you mean? What is ml? It means the magnetic quantum number. Actually, it represents the directions of the orbitals, right? Okay, let's see. Yeah, okay, write this. Sorry, I erased this. 1s to 2s2, 2p6, 3s2, 3p6, 4s2, and 3, 5 and 4s2. Okay, now look at this. We are looking at ml equals minus 1. Now if you look at the S sub energy level, we have a magnetic quantum number of 0 only. P sub energy level, it has what? Minus 1, 0 and plus 1 as magnetic quantum numbers. D sub energy level, it has what? Minus 2, minus 1, 0, plus 1, plus 2. Actually, these are directions. These numbers represent the directions of orientations of orbitals, right? Okay, now look at this. So they're asking for ml equals minus 1, right? P sub energy level has minus 1. D sub energy level has minus 1. But how many electrons have it? No? Okay, you'll understand it better now. I can represent the P sub energy level like this with orbitals. Okay. P sub energy level has 3 orbitals like this. Each orbital can carry up to a maximum of 2 electrons. A maximum. So here, can you see, when I look at 2p6, I can have what? 6 electrons within the p orbital, and I represent it like this. First electrons are filled singly, and then antiparallel, like this. Okay. So here, I can represent minus 1, here I can represent 0, here plus 1. Oh, it's clear. So you can see 2 electrons within what? The p sub energy level, right, has ml equals minus 1. So ml equals minus 1 is prescribed for 2 electrons within the p sub energy level. I hope it's clear. So here I can see 2 electrons. In the S sub energy level, I don't have ml equals minus 1, so forget about the sub energy level. But the D sub energy level, you have to see that there are 5 orbitals when you consider the D sub energy level. So 5 orbitals, 1, 2, 3, 4, 5. So, but there are 5 electrons. Then how do I fill the 5 electrons? Like so, 1, 2, 3, 4, 5. First they are filled singly and then antiparallel, right? So I can represent minus 2 magnetic quantum number, minus 1, 0, plus 1 and plus 2, right? So look at this. Now can you see very carefully, like only 1 electron has this ml equals minus 1 value. Only 1 electron has what? The ml equals minus 1 value. Very important conclusion, right? Then if you consider the D sub energy level, we have only what? 1 electron. But the 3p6 has what? 2 electrons as well, because 2p6 has 2 electrons. Then altogether we have what? 2, 2, 1. We have 5 electrons having the magnetic quantum number of minus 1, right? So the answer is the answer is 8 and what? 5. 8 and 5. That means the third one is the answer, right? Okay, let's come to the next question soon. Question number 3. So now we have to do the 4th question. The 3rd question, I guess. Yeah, 3rd question. So what's that asking you? M is an element that belongs to the 2nd period in the periodic table. It forms a covalent molecule MCO3, which has a dipole moment, right? The group of the periodic table to which M belongs is. Now, in the 2nd period, we have what? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Yeah, but something that forms like MCl3, no? We can have BCl3. B is boron, B is boron, and C is chlorine. So we have something like this. BCl3. Here, chlorine is attracting electrons towards itself because its electronegativity is higher than boron. So then the resultant force is 0, right? So the dipole moment is 0. To the symmetry, it cancels off, right? So what can you say? If the dipole moment is 0, it's a non-polar molecule, right? Okay, but there are polar bonds. Now these are polar bonds, right? It's a very important point. Polar bonds are there because these delta positive, these delta negative. More electrons are towards chlorine. But overall this molecule is what? Non-polar, right? Overall the molecule is non-polar, though it has polar bonds because the dipole moment is 0. But if you consider something like nitrogen, what can you say? Yeah, it forms NCl3, right? Nitrogen forms NCl3. So nitrogen forms NCl3. What can you say about NCl3? Actually, electronegativity of chlorine is like 3 point scale. Nitrogen is like 3. So then I don't have to mark delta positive, delta negative because yeah, obviously nitrogen may be having a little bit of different electronegativity value, but we're not talking about the differences here because you're focusing on the lone pair. The lone pair is the factor that creates this dipole moment. So dipole moment is not equal to what? 0. You can see that, right? The dipole moment is not equal to 0. Therefore, this molecule overall is what? A polar molecule, right? Okay. So the answer then is group 15 because nitrogen belongs to group 15 and it belongs to it, the second period as well, right? Okay, so look at question number 4. They're asking the number of unstable Lewis structures that can be drawn for the peroxynitric acid molecule, right? So we have the peroxynitric acid molecule, HOONOO, something like this, right? So this is the stable structure. This is stable because the formal charge is less, right? But when does a molecule become unstable? The molecule becomes unstable when you have a lot of formal charges, right? When you have a lot of formal charges. Like when oxygen, for example, has a positive charge, it's unstable. Why? Because oxygen is an electronegative element. So when an electronegative element like oxygen gets a positive charge to itself, what happens? It's going to be unstable, right? So remember that point. So let's put positive charges on oxygen to make it unstable, right? So to form unstable Lewis structures, what should we do? We should have a maximum amount of what? Formal charges. What's the number of formal charges, right? So then HOONOO, between oxygen I can have a double bond. Let's see what happens, right? Then here it's going to be positive, this is positive. I should have two negative charges to cancel the positives, then negative, negative, right? Use this technique, these are very easy. So yeah, lone pair nitrogen, right? So these two negative charges cancel the two positive charges, and oxygen, which is electronegative, has what? Positive charge. So it's unstable. Another one, you can put oxygen, you can put what? A double bond between oxygen and nitrogen. So HOONOO, right? So negative, negative, right? So this is positive, and this is positive, right? This is positive and this is positive. Nitrogen has 4 bonds, therefore positive, right? Okay, now see, this is the second structure that I can draw. These are the two possible unstable structures that I can draw because oxygen here has what? Positive charge, right? And there are too many formal charges, therefore it's unstable, right? So there are two possible structures. Okay, look at the 5th question. The UPAC name of the given compound is, so let's draw the compound, right? These are very easy topics. These questions are repeating every day, so practice from 2011 to 2022 at least, right? Okay, so then you'll get through these questions very easily, right? So CH2, OH, and then we have CH, CH3, C double bond O, and we have CH, CH, and Br. Now listen, What is the major functional group here? Yeah, the ketone group. No, can you see that? This is known as on. Because it's the functional group, it's known as on. The ketone group is the main functional group here, right? And these are going to act, if this is the main functional group, these are going to act as what? Substituent groups, CH3, OH, right? Now listen, these are substituent groups. But this is the functional group, main functional group. Now then the main functional group, you know the theory, the main functional group should get the minimum number for the carbon number, right? So when you are selecting, you have to select the longest carbon chain. First you are selecting the longest carbon chain, and when you are selecting the longest carbon chain, the functional group should get the lowest carbon number, right? But the thing is this, now this is the longest carbon chain that I'm going to choose, right? Longest carbon chain I'm going to choose. Then it has what? 1, 2, 3, 4, 5 carbons, therefore it's pent, right? But the thing is this, if I start from this direction, I get 1, 2, 3, third number for the ketone carbon, right? If I start from here, 1, 2, 3, again third number for what? The ketone carbon. Then this theory, you have to focus on the unsaturated groups. Like alkene, it gets what? The lowest carbon number. So that's the theory. Not any other functional group. We have to start with giving the lowest carbon number. Now for the unsaturated functional groups like alkene, right? First, we are giving most prominence. If you have alkene and alkyne, you have to give prominence to alkyne, right? But here it's alkene, therefore I'm going to give what? Carbon number 1 for this. 2, 3, 4, 5. Yeah. So from that itself, you can understand something, that you have to name it as 1-bromo, right? Should be labeled as what? 1-bromo, nothing else. Therefore, you can remove answers like 2 and 4 because according to the alphabetical order we earlier naming, bromo, right? Then hydroxy, alphabetical order, no? Right? Then methyl, alphabetical order, right? So, and also knowing that, now you should understand we can remove answers 2 and 4. Why can we remove answers 2 and 4? We can remove answers 2 and 4 because they have 5 bromo in it. We had to have 1 bromo, so 2 and 4 can be eliminated. And the functional group should be ending with what? On, no? Because it's a ketone, right? So then we can remove answers 4 and 5, right? 4 and 5. So then now we are remaining what? Answers 1 and 3. Only answers 1 and 3 are remaining. Okay, we can get, very easily can get the answer. Only 1 and 3 are remaining. So when you consider 1 and 3, you know that hydroxyl should come before what? Methyl. No, it should be 5-hydroxyl, then what? 4-methyl. So from that itself, you can see that the answer is the third one, right? So you don't have to even formulate the entire answer. So you can use this trick. So the answer is 1-bromo. Then you have to write what? 5-hydroxy. Then you should write what? 4-methyl, because methyl group is attached to the 4th carbon. Then what? Pent 1-ene, because the alkene group is on ene. And then what? 3-on, because it's the main functional group is ketone. I hope you understood this. Right, so now we finished discussing the first 5 MCQs. Thoroughly understand these MCQs, right? Okay.